Good evening, everyone. And today I'm gonna briefly introduce about linked lists. And there are basically two different ways of storing the data. The first way is to store data in a consecutive order. Such an example is the array. When we're given a starting location of the size of the data type, we can easily retrieve the data stored at position I by adding I times the size of the data we want to store to the starting address, and we can get the data at that position. And the second way is that all the data is stored in an unconsecutive order, either in our memory or in our disk. And however, if a collection of data is not stored side by side, how can we get access to the next element? This actually brings to the topic of the linked list. The linked list is a very basic data structure. A very simple linked list consists of different nodes, and where each node contains the data, which is here, it can either be integer, float, boolean, or the kind of data or class or struct you build by your own, and a pointer, or in Java, the reference that contains the address to the next node here that is supposed to be connected to. The linked list usually refers to the start of the collection of the nodes, and the last node of the list usually points to now or now pointer, which means the end of the list. So in this example, we have three different nodes. Here, if we say this is the head, and this is, so head basically refers to the first node in the linked list, and then the data, for example, we have integer stored here, can be 1, and the pointer points to the location of the second node, which is here. And the second node contains data, we say integer 2, and the pointer points to the location of the last node, which is here. And here we say integer 3 is stored here, and the last node will actually point to now or now pointer, which means the last node in this linked list. Unlike the array, when we want to get access to the data at position I, we can get it instantly. But for linked list, only the previous node knows the address of the next node. So we have to traverse the list from the head to get to the ith node, which has the data we want. However, deleting and inserting is quite efficient. I'll show it on my screen here. So again, we have a linked list, which is length 3 here and here, and this is a linked list of length 3, as you can see. And right now, what we want to do is first we want to try to delete the second node in this linked list. So all we have to do is to delete, I'll use a different color here, delete this reference. We will change the location in the head. We'll change the pointer that the head, we'll change the location that the pointer in the head points to. We'll basically let it skip the second node and points directly to the third node. Also, the third node actually points to now here. And then this way, when we actually traverse from the head, we will skip the second node and directly get to the third node, which somehow we delete the second node, but we actually didn't delete it directly in our memory. In Java, the garbage collector will later deal with the data that we will no longer use. And insert is also quite simple. Let me go back a little bit. Suppose we still have this linked list of length 3. Also, this points to now, this last, which means the last pointer, the last node in this list. And if we want to insert this node to position 1, 2, 3 to position 3, all we have to do is this. We first, let me use a different color. We first delete this reference, we let the pointer of the second node points to this node that we want to add to here. And then we point this, we let the, we point this pointer to the last node here in our data structure. This way, this reference is deleted, and if we traverse from the head, we can see we go through this node first, and we go here, and we go here, and we go here, and this actually serves the purpose of like adding a node to our original linked list. And if we want to, and this is actually the biggest advantage of linked list, which is quite efficient at adding and deleting a specific element inside the collection data collection. And if we want to delete or add something in an array, we have to move everything after certain index right one position, and then we put that data at the position we want to add to. This might be quite time consuming. And so this is basically the basic knowledge of linked list. Thank you for watching.